All right, lesson 18-3, the triangle proportionality theorem. This is not a difficult thing to learn at all. However, it is very, very, very important that you don't confuse it with something that you've already learned. We'll get there in just a minute, but surely you're recognizing this picture. Yeah, we did this a while ago, didn't we? Yes, we did. That's why I said it's easy to confuse this with something that we've already done. It'll distinguish itself in just a second. So let's go ahead and walk through this question. It says she wants to find the distance across the lake. So in this problem, it says we know that MR right here is parallel to ST. And knowing that these two right here are parallel are going to help me come up with another pair of angles. We've got the pair of angles up here because remember, this is two triangles nestled inside one another. We've got the little triangle and we've got the big triangle. So angle A is the same for each triangle. So that's why we have a pair of angles right there by the reflexive property. Then because these two are parallel lines, this thing right here is a transversal. So since that's a transversal, this angle right here, angle M, is going to be congruent to angle S because they're corresponding angles. It might be hard to see because we don't have the rest of that line. So I'm just going to real quick. There's MR, there's ST. Here's that transversal. Now maybe you can see the corresponding angles better. Okay. Corresponding meaning that they're in the same portion of the location. So like at this intersection, this angle M that we're talking about right here, for that intersection, it's the top right angle. And for this intersection, different than this one, this intersection, angle S right there is in the top left position. So they're both top left angles. So that's what makes them corresponding. And since they're corresponding, they're congruent. Now, angle R and angle T are congruent for the exact same reason. They are also corresponding angles, just a different pair. Here's the parallel lines and here's the transversal. And they're the top left corresponding angles. But we only need two. So explain why these two triangles are similar. They're similar by angle similarity. Okay, so knowing that corresponding sides of similar triangles are proportional, complete this proportion. So they've got AM proportional to AS and AR is proportional then to AT. AT is what would go there. So you've got the little triangle. I always like to separate mine. And then you've got the big triangle. So this is MAR. This is SAT. And we just did this side is similar to this side, is proportional to this side. And this side right here, we wrote as a ratio with this side right here. Okay, so now they want us to do if AM is 12 and MS. Well, MS is not part of my ratio, so I need to see my picture. So AM is 12 and MS is 9 and AR is 15. Now we had to do this a while ago. How would we determine what RT is? Well, if we're using the proportion that we learned a while ago, we would have to do AM, which is 12, over AS, which is 12 plus 9. 12 plus 9, I believe, is 21. And that's equal to AR is 15. And then then AT is going to be 15 plus, and I like to use X. You could go ahead and say RT right there if you want to, but I like to use X because I'm an algebra teacher. So now we would solve this by cross multiplying, and we would say 12 times 15 plus X is equal to 21 times 15. And then 12 times 15, we have to distribute this 12 right here. So 12 times 15 is 180 plus 12x, and that's equal to 21 times 15. That's 315. Finish my problem over here. I'm going to subtract 180 from both sides. 12x equals 315 minus 180. So that's going to give me 135. 12x equals 135. Divide by 12, divide by 12, and x is 11.25. Okay, so we just found RT. We called it X, but RT is 11.25. RT is 11.25. Now it says MS is 8. MS is 8. And AR is 25. And RT is 10. Find AM. Okay, we could go through that same process. Again, we would call this X. And then we would say AM, which is X over X plus 8, is equal to 25 over 35. And we got that 35 from adding those two together. You cross multiply. 35x is equal to 25 times x plus 8. You do 35x equal 25x plus, what's 25 times 8? 25, 8 quarters, that's 200. Yep. And this time I'm going to subtract 25 x's from both sides, so all of my x's will be on the left-hand side. That's going to leave me 10 x's is equal to 200. Divide both sides by 10, and x is equal to 20. And x was the distance of AM. Okay, so that's nothing different than what we did a while ago. What we did just a few minutes ago, we did little triangle in proportion to the big triangle. I'm going to go ahead and stop the video right here. The next thing that we're going to do, no, we're not going to do this. You can work, I'm going to show you the answer to this proof when I provide you with the answer key. This is not a proof that you would have to do. It's pretty long and it's got a lot of algebra in it, and we're just not going to ask you to do that. But I want to stop and make sure that I think I need to show you something else, but I really need to reference the Springboard book real quick before I go on. And I don't want to rattle on and then have to redo this. So I'm going to go ahead and stop this video. Probably am going to have to tell you or show you something else in a minute. Then you can do this, and then we'll pick up and go and do number 6 and 7 and 8. Okay, so be back in just a minute.